In grade 10 maths, we learn a new theorem, and it's a theorem known as the midpoint theorem. And we're going to rely on it heavily this year, and then it's going to come back to visit us when we go to matric. So please make sure that you get a good foundation in this now. Okay, so the midpoint theorem works like this. If I'm given a triangle, and within that triangle there's another line, but it works out that this length here, AD, is equal to BD, and this length here, AE, is equal to EC, then I can make some conclusions. So let's write this down. Okay, so if AD is equal to BD and AE is equal to EC. Okay, and you'll see now where this gets its name from, because essentially what's happening is this is the midpoint and this is the midpoint of that side. Okay, so if that is true, then we may conclude two things. The first thing is that DE is parallel to BC, so we're allowed to now say that. That's true. And DE is equal to half the length of BC. Okay, so two bits of information there. That is known as the midpoint theorem there. Okay, theorem is always true. Then sometimes this theorem comes to us in what is known as the converse. So they give us a bit of back to front information, but we can make similar deductions. So let's have a look at the information we've got. We've got one midpoint here at I over there, because we can see that this is equal to that. And then we've been given a parallel side there. Do you see those little arrows? Okay, so let's have a look at what the converse would look like. It would say if I is equal to GI, okay, in other words, we've got the midpoint, and we've got some parallel lines, IJ is parallel to GH, then what is true? Well, it's just the things that were given to us in the previous version of this theorem. So then we can say if J is equal to HJ, and we can say IJ is equal to half the length of GH. Okay, so that's the midpoint theorem, and once you understand it, the trick becomes spotting it. Okay, so whenever you're given, it looks like a triangle in a triangle, and you've got some parallel sides or you've got some equal lines, that's when you want to be looking out for this theorem in action. Let's have a look at some examples that we can expect to see. So consider the sketch below. Here we go, we've definitely got a triangle and a triangle. So I'm already thinking midpoint theorem is going to be a thing. There's a bit of an extension here. I'm noticing some parallel lines. Let's color code here so we don't miss anything. That and that is given to us as parallel. Okay, then we were given some equal line segments, so there we go, which means we've definitely got a midpoint there. Okay, we're given some more. This one and this one are equal, so we've got a midpoint there at E. Okay, so there's enough information here definitely to talk about the midpoint theorem. Okay, so what they're asking us for is the length of DE. Okay, so that's the internal side there. Okay, so what do I know? I know that if I've got a midpoint on either side, and if I've got midpoint here and midpoint here, then I can deduce this and this is parallel, and this side is equal to half of that side. So we just need to state that. So we are given the following information. Let's write it down for them. AD is equal to BD. That was given to us. Then AE is equal to EC. That was also given to us. Okay, and so therefore we can conclude two things. DE is parallel to BC, and we can say that DE is equal to half the length of BC. Okay, and the reason for each of these is the midpoint theorem. Okay, so midpoint theorem there. Okay, and so now I can just work it out. If I know what BC is equal to, I can definitely answer their question. So I can say, well, DE is equal to half of 32. and that means that it is equal to 16 centimeters there. Okay, and now they say prove that, this is our next question, BCFD is a parallelogram. Okay, so let's try and have a look at that. BCFD is a parallelogram. Okay, there we go. What do we need to be able to prove that something is a parallelogram? This is bringing all of our knowledge together. Okay, so in order to prove a parallelogram, I need to be able to prove two pairs of opposite sides are parallel, or two pairs of opposite sides are equal in length. I can also prove that the opposite angles are equal, because that's true of a parallelogram, or the diagonals, but we don't even have diagonals here, so I wouldn't go that route. But let's see if we can do something with the side lengths here. Okay, so opposite sides equal, possibly, but I think what's more helpful is the fact that they've already given us some parallel lines. Do you see that? This one and this one here have been given to us as parallel. And we've already proven in part that this and this is parallel. So let's build on that, and that way we'll be able to prove that this is a parallelogram. Okay, so that was question 1. This is question 2. Okay, so starting off, we're going to say BD is parallel to CF. That was given. And then we're going to say DE is parallel to BC. We proved that in the previous question, so proven. But DE is not quite the whole side length. Do you see that? We need to prove it's all the way to DF. Okay, but we can just say that. But EF is an extension of DE. So therefore, we can say that DF, we can use the whole of DF instead of that DE there. So therefore, DF is parallel to BC. Okay, and so now I've proven, look at that, I've got parallel sides, I've got parallel sides. Nice. Oh, let's get the double there. Okay, and so now I can conclude, therefore, to answer their question, BCFD is a parallelogram, and the reason two pairs of opposite sides are parallel. Let's have a look at an example that looks a little bit more tricky. Okay, so given, now they've told us all of these equal things. Okay, PQ is equal to QR, and PU is equal to UT and TS. Okay, so lots happening there. Then they say VT over there is equal to 15 meters. So that information is not on the sketch. Let's get it in there, that section. Okay, calculate the length of RT. So the unknown here is this whole side here, RT. Let's color code that. RT. There we go. Okay, that's what we want. Now we need to somehow build our knowledge. This is very cool, actually. So look at this. I can see that this is a side in a triangle here where I've got some midpoints. Okay, because, let's color code this so that you can see what I see. If that and that is equal, that means Q is a midpoint. And if that and that is equal, it means that U is a midpoint of this upper triangle here. Okay, but unfortunately we don't have enough information there. The reason I like this upper triangle is because the side that I want actually is part of that triangle, so that would help me. But I would need to get this section here first, because I know midpoint theorem says parallel, and this is half as long as that. Okay, but let's not worry too much, because I've got more than one triangle happening over here. Okay, and I've got some further equal sides. So I've got that this and this is equal, meaning that this is a midpoint. Okay, so that puts us in another triangle, this one here. All right, lots going on. So I don't quite have a midpoint theorem here. I hope you see that. I've got only one midpoint. I don't have a midpoint on this side yet. So we're going to have to really jump from triangle to triangle to triangle here. Okay, because if I can show that these are parallel, then I can say, well, cool, then that's also a midpoint. So let's go for it. Okay, in the blue triangle, so we're going to tell our marker that we are working in triangle PRS. No, PRT. PRT is our first blue triangle. Okay, we are given the fact that PQ is equal to QR and PU is equal to UT. So that was given to us. So therefore, we can say two things. QU is equal to half the length of RT. Okay, ooh, midpoint theorem there. And we can say that QU is parallel to RT, also because of the midpoint theorem. Okay, so now I've got some parallel lines over there and there. I've proven that. Okay, now we're going to move. We're going to change gears slightly. Let's move into this greenish triangle that I highlighted. So in triangle QUS. Okay, what do we know there? We know that UT is equal to TS. That was given to us. Okay, and we know, because we've just proven it, that QU is parallel to VT. That's something we've proven. Okay, why was I interested in that? Because that means the midpoint theorem is true. That means that this side here is equal to this side here, if I need it to be. And it means that the length here, let's get a nice popping color. This 15 is half of the length of that QU. So even though it's upside down, I hope you can spot that. So I can then say, therefore, QU is equal to 2 times, because it's the longer side there, VT, okay, midpoint, or actually it's the converse. So QU is equal to 2 times 15, which is 30 meters. Okay, 30 meters. And now we're going to jump back into that first triangle that we worked in, and we're going to say in triangle PRT, we have already proven the midpoint theorem there. Do you see that? So we said QU is equal to half of RT. So let's write that. QU equals a half RT. We proved that already. And so now we know that QU is 30 is equal to a half of RT, the missing side. Okay, let's divide both sides here by a half. And it's very interesting when you divide by a fraction like that. What you'll find is that RT is equal to 60 meters, because technically we're going to tip in times. And that does make sense. RT does look like it could be 60 meters there. Okay, so because we had the midpoint theorem, we can say this is parallel to this and half as long. But we had more than one triangle to work in, and remember that can always be the case. So over here, we had this is equal to this. We proved some parallel lines, and so then we had the converse of the midpoint theorem, where it was like this side and this side also creates a midpoint over there at V, and then we can apply the same thing. VT was half as long as QU. Okay, so the key is to just keep looking for midpoints. Okay, there's a reason why they gave us all of these equal sides. Use it to your advantage, and the more you practice, the better you will get at these types of questions. So practice, practice, practice.